In this section, we're going to look at systems with two variables. This is a continuation, and we're going to look at the elimination method. With the elimination method, we're going to choose a letter to eliminate. We're going to multiply one or both equations by a constant to obtain the positive least common multiple and the negative least common multiple of the letter you chose to eliminate. Then we're going to add the equations together, solve for the other letter, and back substitute into either of the original equations to find the first letter that you eliminated. Sounds hard, but not very hard. Let's look at an example. If we have x plus y equals 1 and 5x plus 3y equals negative 1, the first thing we need to do is choose a letter to eliminate. I'm going to eliminate the x's. If I look at the equations, my x terms have a positive 1 and a positive 5 right now as the leading coefficients. The least common multiple will be a 5, so I need to make one of them a 5 and one of them a negative 5. I'm going to leave equation 2 alone because it's already a 5 and just copy down 5x plus 3y equals negative 1. Equation 1, I want to have a negative 5x, so I'm going to multiply the whole equation by a negative 5. That's going to give me a negative 5x minus a 5y will then equal a negative 5. Now, I add the two equations together. Notice that my x's will drop off. I have negative 2y equals negative 6. When I divide both sides by a negative 2, I can see that the y answer is going to be 3. Halfway there, got the y. Now all I have to do is back substitute to get the x. You can go into either one of the original equations. I always choose the first equation, x plus y equals 1, but we now know that the y is 3. So x plus 3 equals 1, and when I subtract 3 from both sides, I'm going to see that x equals a negative 2. So negative 2, 3 will be the point where both of these lines intersect. Let's go to another example. Let's look at 4x minus 3y equals 6 and 5x minus 10y equals a negative 5. We need to choose a letter to eliminate from the beginning. If I choose to eliminate the x's, I need to look at my x terms, which are 4x and 5x, and decide the least common multiple. Least common multiple of 4 and 5 is going to be 20, so I need to make one of these a positive 20 and the other one a negative 20. If I multiply equation 1 times 5, I'm going to have the positive 20x. Continuing multiplying the rest of the equation is going to give me minus 15y is equal to 30. Now I need equation 2 to have a negative 20x, so they'll eliminate. To make a 5x into a negative 20x, I'm going to multiply the whole equation by a negative 4. Negative 4 times 5x is negative 20x. Negative 4 times negative 10y is going to be a positive 40y. And negative 4 times a negative 5 is going to give me a positive 20. At this point, I add the two equations together and notice that my x does eliminate. 40 and a negative 15 are going to give me a positive 25y. That's going to equal a positive 50. Divide both sides by that 25, and I'll notice that y is going to equal a positive 2. At this point, since I have the y, I need to solve for the x. Back substitute into either one of the original equations. I'm going to look at equation 1. Instead of the y, I'm going to use the y I just solved for, or 2. So 4x minus 6 is equal to 6. When I add 6 to both sides, I'm going to see that 4x is going to equal 12, therefore telling me that x is going to equal 3. Now, it's a good idea to double check these in your answer into both equations, and you can do this easily by the calculator. With your first equation, you're going to type 4 times our x, which is 3, minus 3 times our y, which is 2. Make sure it equals the right-hand side, which it does, of 6. Double check into the other equation, 5 times our x, which is 3, minus 10 times our y, which is 2, and you'll notice that it equals a -5. This will always show you if you've made a careless mistake somewhere. The answer has to check into both of the original equations. Another example, looking at 4x minus 2y equals 5 and 6x minus 3y equals a -10. Choose a letter to eliminate. Since I've been using x's, I'll choose a y on this one. The least common multiple of my y's of -2 and -3 is going to be a 6. I need to make one of those y's a positive 6y and the other one a -6y. In order to make a positive 6y, I can multiply equation 1 by a -3, and that will give me a -12x plus 6y is going to equal a -15. Since I need the second equation to be a -6y, all I have to do is multiply that whole equation by 2. That's going to give me a positive 12x minus 6y is going to equal a -10. Notice when I add those together, my x terms cancel out, and so do my y terms. So my left-hand side is just going to be 0. My right-hand side is going to be -15. Or -25, excuse me, -15 plus -10. 0 equals -25 is a false solution. That is not true. That means if we were graphing these lines would graph to be parallel lines. No solution to this problem. Again, when your letters drop off and your answer is false, there's not going to be a solution. Let's look at another case where our letters are going to drop off. Choose a letter to eliminate. In this case, I'm going to choose to eliminate the x's. The least common multiple of +2 and -4 is going to be a 4. I need to make one of the x terms a +4, the other x term a -4. Since equation number 2 already has the -4x, I'm just going to copy it down. I need to turn equation 1 into a +4x, so I'm going to multiply that by the constant of 2 to give me 4x minus 6y is going to equal a -2. When I add the equations together, the x's cancel, the y's cancel, so the left-hand side is 0. On the right-hand side, -2 plus 2 equals 0. So the letters dropped off, and 0 equals 0 is now a true statement. When the letters drop off and what's left is true, we're going to say that every point on the equation is a solution to the other one. So I'm going to put in set builder notation all points x and y such that 2x minus 3y equals -1. Every point on that line will make the other line true, because if we looked at these graphically, these lines would actually graph directly on top of each other. They're the exact same line.